Right. Are we live? I'm seeing an error occurred. Please try again later. But it says you're live. So who do I believe? YouTube. Who do I believe? Who can I trust in these trying times? Okay, there we go. Let's go in now. Okay, I do declare now that we are live. Hello, everyone. Hope you guys are doing good. Watching the people watching the VODs at home. It is your boy, the cabin guy, here with another day of doing some C coding. I don't know what to call these streams, dude. I really don't. So, yeah. Anywho, we got some stuff on the agenda today. If I can, I should really actually just write a bash script that like lets me navigate or set up my workspace for this project. But whatever. We'll just keep working here as is. So, right. Tracks, let's go there. We're going to talk about what's on the agenda for today. What's on the agenda for your boy, Cozy. There we go. Alright, beautiful. Go into our beautiful vim.c. And let's talk about what we're going to do today. So, last stream we were working on, or the last coding stream, we were working on doing some matrix stuff. And I was using a very simplified matrix, but I decided to instead use an affine transformation matrix. It just seemed, in general, more appropriate for what I'm doing here. And that's not it. What happened? I had ya. Okay, let's try this again. Session data. It's being mad. Maybe editing the same file. If this is the case, the edit session for this file crashed. Use recover or vim. Yeah, we're gonna use recover. I guess 1. Anywho, I'm guessing that's the one. That's the latest one. Yeah, June 16th. Yeah. Okay, let's go here. Yes, the affine transformation matrix. What's going on, Epic Sandstorm? Hey, brother. How we doing today, man? We're just getting started. So. Last stream we were doing some transform matrix stuff, and I think what we're going to do is actually continue with this and get this wrapped up. Once that's done, I want to try doing something a little bit more spicy. I want to try learning some AVX stuff. I've been wanting to do it for a while. I've seen it here and there. But you know what? Maybe now's the time to actually start doing it. Maybe today we take our, we can start something simple and take our, or maybe I'll make a separate project entirely. And use that for testing this out, and then we'll learn how to do it. But yeah, I think it's high time we learn. And there's a nice GitHub tutorial about how to use intrinsics. So yeah, I think it'd be kind of cool to start learning how to hand roll some of this stuff. Anywho, so yeah, I think that's like the two things I have in mind. Something else I want to do is potentially learn how to do some mouse inputs. Apparently, you can actually get mouse inputs through ANSI escape codes. So want this game engine to be able to take in mouse inputs. That seems kind of importante. So I'm thinking, just maybe, we can take a look at it. Yeah, there's some basic stuff for like hiding mouse, or cursor. My bad. Yeah, moves cursor. No, it says cursor. No, there's a mouse thing specifically. So we might take a look at that. Yeah, this is the color stuff. Yeah. I'm trying to find it. You also might want to look at making our input handling a bit more robust, but we're living, right? We're vibing. So, yeah, that's the agenda. Finish the transform stuff, hopefully get it working. Maybe do some AVX, maybe do some mouse inputs. And maybe start building out some application logic. Clang? More like claim. Because it's lame. Man. We do a little joshing. Let's see here. Also, I might put on some background music. Some chill stuff. That doesn't sound half bad. What kind of vibe are we gonna listen to? There's Zelda music. I can go for some relaxing Zelda music, ambient stuff. That doesn't sound half bad. Yeah, that sounds good to me, dude. The yawn. I'm just saying, man. GCC's kind of peak, dude. It's all a man needs. Everything beyond GCC is a downhill. Alright, I'm joshing. I'm not gonna lie, I think maybe at some point I'll like upgrade this to change all the extensions to C++ files and do some stuff there, but just so I can have like operator overloading. But we'll see. We're gonna ride this out, dude. So yeah, I've changed my mind, and this is no longer gonna be a local space thing, but a world space coordinate. I'm thinking. And instead, get world position would simply be, I mean, honestly, this gets simplified in a weird way for an object, because now world position's indicated by these values here. So in truth, I can actually remove these bad boys. And instead, we can return F2. And what columns do we need? Pardon me. Alright, we don't have to actually do the matrix thing. We can like legitimately return, what was it? Yeah, we can literally just return this. Is it a float 3? I think it's a float 3 though. Yeah. Because we're effectively just treating everything as a 2D. As 2D, and then the Z coordinate is like more for depth stuff, but like we're not actually using that for. Are we gonna? Should I actually make this a 3D affine transformation instead of a 2D affine transformation matrix? Oh, brother. What is a gamer to do, man? Intel. What about Intel? I say when we do the AVX stuff, though, we're going to have to look at the, what, do I have it here? AVX has, Intel has this nice kind of documentation for all the AVX, or vector extensions, intrinsic stuff. I'm sorry, can we please have this be in night mode? Oh. There we go. Splendid. So I'm probably gonna be hunting through this a little bit and potentially looking at I don't know, I actually might start with just looking at SSE, because I wanna, that's like the minimum level I want to be able to support, I think. And then we can do a variance based off of this. But if I go to like AVX2, I might actually start considering doing a bit of a different structure for everything. But I need to actually learn how to like just use it first, and then we can make more pertinent design decisions. Yeah, what do? We do arithmetic, and then you have your ads. I forgot which one. I think PD is the floating point one, or is it PS? Add a pack, single precision, 32-bit floating point. Okay, yeah, that's, so this would be the one we'd use, I think, for our vector add instruction. But this is using like a 256-bit register, I think. So we'll see. What is your keyboard? What's the name of a? Here it is. This music feels a little somber. Let's try this. Okay, a little bit better. I can dig this. Okay, cool. I lost my passion. My job monitors us to ensure we use AI, so lately I don't even code anymore. Today I spent all day writing prompts. That sounds absolutely miserable, dude. I'm sorry to hear that, man. I'm sorry to hear that you have to do that at your work. Yeah, I have that same kind of issue. Not to that same degree, though, but there's like a increasing desire for it at my job, and like there's people I very much respect who are super into it, and but at least at work there's like a little bit of a freedom to kind of figure out where the line is. I'm on a big extreme of like, I really want to learn, so I don't want to use it at all and lose some fundamental abilities. But the fact that you're forced to use AI is really sad, dude. But I mean, all you can really do is either supplement your learning by working on your own personal projects, or get another job. Easier said, but it just reminds me of that whole Jonathan Blow thing where he's like, someone's like, hey, I got a job doing web and JavaScript. He's like, what can I do for my career? And he's like, quit your job and get a real one. Because like, if you spend 8 hours a day doing work that's not making you better, but instead conditioning you to like do bad, mediocre work, then you start losing the capabilities to do that high level, artisanal, high level stuff. Oh snap, what's going on, Sia? Good to see you today. Hopefully all is well in your 3D work day. Or last time you mentioned you're doing planning, right? Either way, cheers. Secret option number 3, sabotage the company. Oh yeah, but then you end up having a secret option number 3 leads you to doing option number 2, getting another job. Now we modeling now? Let's go, dude. Let's go. Yeah, vertical chat and horizontal chat. We got a top tier 3D modeler doing some modeling now. But yeah, it's like I'm sorry to hear that, dude. But hey, we're here and we're in a space where we don't have to do that. We're actually learning, trying to get good, doing some conceptual math stuff here, and then we're gonna do that cool low level stuff, ultra low level stuff And we could talk about like what this is, because it's super really cool, and I don't think many people are aware of it, or they never get to this, like they never have to deal with problems where this becomes a consideration. But SIMD's cool. We love doing SIMD, single instruction, multiple data. You love to see it. And as fun as it is to have vector types that aren't SIMD optimized, we could probably do that. So yeah, we can talk about that. I mean, I'm not an expert on it. We're gonna be learning about it today, but I can share my basic understanding of it, and then we'll see how we go at tackling this. Should I move to the other stream? Why do people like vertical? I guess because the vertical stream, like the YouTube Shorts, interjects live in there. Vertical stream is like the Wild West though. Like it fluctuates like crazy. Like sometimes it's like we've gone through seasons where it's like crazy large amount of people there. And I think we're in an off season. I think like winter, this pops up more because like it's cold and people want actual cozy content. Also, I think during school semesters, my streams kind of pop up more. I guess more kids are doing coding, so they get exposed to this. Either way, it's a thing. So, why are we doing this, guys? I started just implementing this, but we never talked about it. So let's 2D affine transformation matrix visualizer. So in most game engines, heck, in a lot of applications that are 3D, you have the idea of a transform. You usually conceptually think about it as like an object that has a position, that has a rotation, and that has a scale. And there's different ways to deal with it, but one way of representing it is using something called an affine transformation matrix. And a transformation matrix allows you to encode all those things into one place. And it's cool because it allows easy transformation of coordinates from something called local space to world space and vice versa. So right now you have an object that's like centered at origin. You can say that, right? And in fact, we can add some entries here. Like a normal object you can think about has like an extended like -1 0 or -1 1 1 1 1 -1, and perchance we will also add. Can I add another point to this? Yes, I can. You'll love to see it. -1 -1. And if you open up is it scaled non-linearly? I think that's what's going on. Yeah, it's not scaled linearly. It's okay. Anyways, you have this box, right? And you have this transformation matrix. So you can plug in these values and multiply by this and you get this result. But let's say I want to, I don't know, let's scale the object up by a factor of 2. And if we change certain parameters in our matrix, you'll see some scaling be done. And if I modify additional parameters here, let's say 2, 2, and apply the transform, oh my goodness, we have translation. And you can also do rotation. It's a little bit more involved. But basically, you can multiply a point by this this matrix, and you'll get its position in the world with all those different factors. And that's what we're doing here, right? We have this definition of the matrix, and you can multiply a point by it, and you'll get the resultant coordinate in some factor. In this case, though, we'd be using this to transform things from world space to local space. There's utilities for that. But yeah, have you ever seen things like Unity, or Unreal, or Godot. Probably GameMaker has this. Objects have this concept baked into them and implemented in some form or fashion. Your GPU is very much well suited for doing matrix mathematics. Your shaders are all going to be piping this kind of matrix information around. And in fact, there's other types of matrix as well, but there's other types of matrix that do other types of things. But we're just grappling with this one right now. Perchance, perhaps, may chance to... What are you saying, Tara? What are you saying, Tara? Also, what's going on, Oliver? What's going on, Oliver? I use Vim and GCC, but you definitely don't want to hear about my dream. What kind of dream do you have, dude? I guess anything's on the table. We're talking Vim and GCC. We're talking Vim and GCC. The world is your oyster. It's like the knowledge of good and evil. So many good and bad things can happen with GCC and Vim. But yeah, so this is the basic idea of a transformation matrix and how they're kind of used within any engine or 3D software or video editing software or anything that has objects that are being rotated around. A lot of times they're doing this kind of math in the back end. So, in our case, we don't need to do a lot of this stuff because we're actually making this matrix for converting to local space. Which means we have to do a bit more math than we initially intended to convert position to local space. Okay, the cool people chat. Yeah, the cool people room. You're in the elite room. Hey, Cozy Cabin. Hey, everyone. How are you doing today? It was a hot dream, esteem. Oh my goodness. I was in the bath. Yeah, the bath would do that to you. The bath would do that for you. So what, you're gonna build a sauna? GCC, compile me a bathroom. GCC, compile me a rubber ducky. Anyways, so I said all this stuff, and it sounds like I know what I'm talking about, but really I'm not, because we're figuring out some weird things here about how we're going to encode information. Because initially we're storing a local position and transforming it into world, but now the assumption is that objects are always oriented at 0, 0 in local space. So this step is kind of redundant, is it not? Is it not redundant? So truly, what we're really using for this is to like this idea of local to world. Like I guess we can multiply. There's some utility of like converting stuff to like a local position. We do need that for the ray casting stuff. So this is still very much relevant. It's just that what the math we're doing there is not quite what we need. Or at least it's a bit incomplete. So we might have to actually structure this a little bit different. So I'm going to yoink this for my own reference. And this is like a local to world matrix because you can multiply some local position and it'll convert it to a world position. You guys are following me, right? We're on the same page. It's super simple, dude. It's self-evident, man. Hey, Asana. Who's Asana? Oh, Asana. Store my error keeps buffering my signal. GG's, dude. Says the guy who doesn't use headers or even other C files. What are you talking about? I'm using only headers, dog. What do you mean, man? Look at me. Look at this. We only use header files. We just don't do a companion C file for it. We don't. We don't. Look, okay, it's so dumb. It's like essentially writing an interface for every single object, every single class. Like, it's like, why would I want to do that, dude? I just want to write the dang thing. Let it be compiled. One unit, dude. Simple. Simple. Life is good. And to have to use like some external thing and things have to change. But it's whatever, man. Whatever. Who cares? Okay. This is 2 local space. So we're taking some world space position and we're constructing this matrix. I might want to keep this matrix instead because it's kind of dumb to have, like, in all honesty, it's kind of dumb to have these structs of floats and everything, or these arrays of floats, just to have to reconstruct a matrix every time I want to do an operation on it. So maybe I should just straight up just have an array of these matrices and then, you know, call it a day. That's not unreasonable, dude. I'm proud of you. You've grown so much. I know. Yes, that's what we do. Yeah, it's right. Like, who wants to do that? No one wants to do that. Like that. Never. Isn't it so heartbreaking? Cause like, there's so many languages, and they have things I like, but none of them just have it. Like, it hurts my soul a little bit. What's happening? What's going on? Call out GB. We're gonna try to get some matrix stuff going here, or we're revising how we do it in our little baby engine. So yeah, I'm rethinking how we're doing stuff. We changed from just using a simple matrix to like one that actually is more robust. So we have to construct. I'm gonna start with this and then we'll eventually correct it, I think. And then I've been doing this ABCD convention, but that seems a little dumb. So I guess we're gonna do the matrix 0 stuff that we usually see, where this is like 0 0, and then this is 1 0, and then 2 0, and then this is 0 1 and 0 2, etc., 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 etc. And you have to evaluate these expressions correctly. So oh, wait a second. Right, because we're accessing things in this fashion. Yeah. So tell me about your day, guys. How was school? How are the kids? How we doing? Let's do that cool thing where we have these aligned. Why not? Why not? And let's also do some reference for ourselves so that we can be on the same page about these coordinates. Zero 1, 0 2, and then you become 1 1, 2 1, I think. 1 2, 2 2. So simple, guys. So simple. Or maybe I should just be... No, I can't. Okay, we'll just deal with this. Vim, yeah, dude. Yeah, syshalt. We're in the... We have all 12 Vim users in this room together. Splendid. All 12 of us. I think the next stream I'm gonna title it "Making a Game in C," and in parentheses, by the way, I use Vim. It's the first thing you do. It's how you start dominance, right? Like, I show up to a job interview, and the first thing I say is not, you know, hello, I'm so and so, I'm cabin guy, nice to meet you. No, it's that you first of all, you don't shake their hands, all right? You say wait, and you pull out your laptop, and then you boot up Vim, and they just stare at all of you, and then they give you the job. They don't, you like, if you guys want to get a technical job, here's the key to cracking the interview. When they give you, like, they give you some algorithm. They give you like a bubble sort algorithm, and they ask you what's the O of N of it. You just say, I'm sorry, I don't even know what that is, okay? I just know Vim. I just know Vim. You say, you know, what's O of N? I don't know what that is, but I do know Vim, by the way. And they go, oh, you should have started with that. Why didn't you say that from the beginning? You're hired. Get in here, dog. Get in there. I feel like I imagine you walking into an interview and spinning those keyboards around, your finger like a gun. Yeah, dude. Just whip it around like a cowboy. Yeah, I need to show up with the... I've joked around about it, but I want to get like some jorts. It has to be jorts. And I want to have these keyboards sewn onto my jorts. So everywhere I walk, I have these two Ergodox keyboards just straddling with me. Cause you never know when you gotta plug in. You never know when you gotta Vim it out. I was doing something, wasn't I? Yes, I was. What was it? Oh yeah, scale times sine times angle. We're gonna be a little bit of a nerd, okay? We're not gonna say angle. We're gonna say theta. Because that's how you signify that you're better than people. You just say... You just use the terms, man. Nothing says qualified than, like, not citing your sources. Hey, I saw that you, like, refactored the entire, code base. But, like, what are you doing? Like, you're just saying, like random things, but, like, why are you doing this? Just trust me, man. You just don't understand. Pause X. Nah, when I interviewed for my job, my current job, I was such a... Dude, I almost walked out of the interview. It's a miracle I have this job. It's legitimately a blessing from God, okay? Legitimately a blessing of God. Because I walked out of the interview thinking that I didn't get the job and that I just crashed and burned. I thought, like, it was, you know, in retrospect, it kind of seems like a power move, but I forced the interview to end early because I was like, hey, I got a meter outside and I don't want to pay another $7 to extend it. So I'm going to cut this portion of the interview short. It was nice meeting you guys. I'll catch you later. I actually did that. I wasn't trying to be, like, that wasn't the intention. I just legitimately didn't want to get the car towed. But I didn't consider the option of just paying for the meter. So yeah, we just said, hey, nice knowing you, but I know this is a great job and great opportunity, but come on, $7 is $7, all right? Greek alert. Greek alert? What's the Greek part? What activated your Greek alarm? Oh, theta. You're right. You're right. Yeah, Greek did get mentioned there. That's the sleeper word for ya in it. Okay, you're gonna be 0, 0, and then 1 for the Z component. I can't get the thought that this is Mr. Krabs running out of my mind ever since Morgan mentioned it all those moons ago. I literally understand nothing, but I hear soothing keyboard sounds, and I can pretend. That's okay, man. That's like my first few years of working. I don't understand what's going on. We smile and nod, smile and wave. Eventually, you start absorbing some knowledge sometimes. Sine A. You're supposed to be sine, and you're supposed to be cos. And not only that, I have this wrong. Scale is supposed to be multiplied here, and why am I multiplying by scale here? That's incorrect. Gosh, man, I'm just all over the place today. Okay, now this is the correct way to build a matrix. Perfect. Math. Yeah, we're doing some bathroom stall math, guys. The scribbles you just see randomly in the... I should go into a bathroom stall with an expo marker and just like write this nonsense. Only like one person's gonna be in there and getting to understand it. Okay, I think we're good. Okay, I need to actually, we're gonna space this out like this. I know this looks deranged. Leave me alone, okay? I need to know what components are being dealt with here, so I can just look at a glance. And this makes sense to me. If I want to be really deranged, we can do this. But no, we're not gonna do that. Okay, we have our matrix, beautiful. Now we have to do our inverse matrix. Yay! However, the way we calculate the inverse matrix here is incomplete, because that's for like a 2 by 2 matrix, and we're doing a 3 by 3 matrix. So I don't know how to do it offhand. So we're just gonna Google 3x3 inverse matrix formula. The Krabby Patty secret formula. Okay, let's see how we make these Krabby Patties. Does anyone have a good... Okay, so far I'm confused, scared. I almost feel inclined to open up a book. And that's a terrifying prospect, isn't it? Isn't it a terrifying prospect? Come on, there's got to be a simple formula for doing the inverse of a 3 by 3 matrix. Like someone's done the thing already. I just need the dude. The guy. Someone. Please. Yeah, yes, Reddit. Reddit. Yes, Reddit. Help me, Reddit. Matrix inverses. Thank you. Thank you. Okay. So for a 3x3 matrix where we have this. Yeah, that's cool. I don't even know what how do you For the product A, B of matrices B can be expressed in terms of A minus inverted. Yes, you can express it like that. Yeah, that's not the notation I'm kind of so what is this? Like the absolute... I need an example. We know this one. And this one's simple. You see, like, you see how easy it is? They even give you an explicit formula. A formioli. You know, you just mirror and then flipped and you just AD BC. Right? That makes sense to me. So, what's going on here? Are these just summations? That's all that is. We're summing up these. Okay, let me turn off the yeah, no, we're not missing something here. That's just what it is. So what, is it just the summation of these coordinates or these entries for each cell? I'm not gonna lie, guys. I'm a little bit lost here. Literally understand nothing. Yep. That's not the absolute. That's the determinant. Okay, thank you, IMK. Now what we need is to know what a determinant is. That's what we need to know. Okay. Example, find the determinant of the given matrix. Okay. So A5, 4, 5. So it's A times 5 minus 4 times 5. Okay. So does that just extend? Oh, I guess we don't have to extend. It's literally just that. So you just do that process for these. So what, multiply this by this minus this by that. A crisscross applesauce. Determinant for a 2x2 matrix. Splendid. Okay. Alright, beautiful. So that's all we're doing is calculating the determinant for these entries. Cool. Now we're cooking. The only thing I don't understand is this. A. But is that the determinant for like... for the determinant of the 3x3 matrix? Actually, that makes sense, because like for the 2x2 one, the scale component was the determinant for the original one. If we go down here, yeah, here, we calculate the determinant there. Okay. So now we just need to know how to do the determinant for a 3x3 matrix. See, we're getting somewhere. Thank you, dude. That helped out a lot. Determinant for 3x3. It's calculated as A times determinant of... Okay, so you create these 2x2 matrices and then do that. Okay. Beautiful. Splendid. I think we have all the recipes we need to cook up this formula, this function. Mommy chupapi. Okay, I can't believe I'm revising. I'm revising for my exam on a YouTube live. What do you mean revising for your exam? Are you making an exam? What the hell does this, Draco? We're doing some matrix, some linear algebra. some simple yet necessary linear algebra. Okay, so let's find. Oh, this is essentially a single valley. So orig determinant, and then we also need to have the determinants for. Okay, this is gonna get very. We're gonna abbreviate it to det, and we have. Where is the, where are you? There you are. So we have 9 different determinants to create here. So M, in fact, we're gonna do this. Nope. Oh, I can't do what I want to do, which is just, oh. Okay. Come on. There we go. Okay, now we have to calculate that. I'm gonna probably make a function to do this. 2x2 determinant. Yeah, it's just float actually. Okay, float B, float C, float D. And it's simply going to return. What was it again? 1 divide. Oh, actually, no, that's for the final result, but the actual determinant on the bottom is A times D minus C times B? Or is it B times C? I mean, it doesn't matter, it's commutative. We have the commutative property. My favorite. I love commutativity. AD minus BC. We're good. But we can make this just match the documentation. Okay, cool. You know what? We might as well. I think I might just do. Yeah, we're gonna do this. There we go. For ease of referencing. Over a little bit. Beautiful. Beautiful, splendid even. Determinant. There we go. And then we're gonna do, are they doing the same convention as me? No, they're not. They're doing it exclusively. I'm doing it inclusively with 0. That's not confusing at all. That means I'm gonna have to do like subtract everything I see, don't I? That's okay. A little math never scared me. Except like right now, but it's okay. That's how you learn. See, that's how you know this is real, because we I don't know everything. We're going through a training arc right now. I keep typing MM because that's like a lot of the abbreviations for AVX stuff. I don't even do it that much. I've been looking at a bunch of it lately. Or at least a little smidgen of it. Okay. 0, 2. 0, 1. 2, 2. 2, 1. Okay, splendid, dude. This is coming together, man. What are we coding? I'm doing some matrix stuff. So I'm adding the matrix structure for our game, and how we're gonna be converting objects. I want to be able to convert points into a local space of an object. So we gotta do some math. Good morning, Zero. It's good to see you. Always good to see you, Zero. Hopefully all is well, man. Don't worry, guys. We're gonna get through this. Maybe soonish. We'll see. And then we'll go back to doing things that you guys can actually see the progress of. Okay. So we're doing, again, the same function, right? Determinant, but now with the correct values. So the second row is going to be 1, 2, 1, 0, 2, 2, and 2, 0. I should really just make this a new line. Also, this needs to be... Oh wait, I'm dumb. We need the M, or the M. There we go. Splendid. In our little cramped view, we're gonna have to really just crunch this bad boy down. Seriously though, how do you do all this hard coding? It's good, it's fun, dude. SBO. I enjoy it. It's like puzzles. Well, it's not. It's more than just puzzles. It's like, you ever grind like in a game, like an RPG or something, or RuneScape? And you know, like for every unit of time you grind, you're getting better at it. That's how it feels like with programming. It's like, I feel like I've been going consistently through these different arcs, learning new things and becoming better at programming, and trying to get as good as I possibly can at this craft, because I really enjoy this craft and I want to do the best with what I have. So I want to see to where can I get to, how far can I go, what am I able to do. So I mean, you've probably seen this theme already recur, but I never take the easy route on any of this stuff. We always go the long way around, but it's, by doing so, I end up learning way more, and I feel much more confident as a programmer. And, you know, it's just cool, dude. It's just cool. Did I do this one right? I don't think I did it right. I don't feel confident it is at all. 0, 2, yeah. 0, 0. 1, 2, yeah. And 1, 0. Oh, we got it right. We actually did it right. Okay, guys, we're on the last row of this 2x2 determinant thing. Cozy is on another level. Well, I'm not there yet. There's people I work with who are like super crazy smart and are doing, like, I don't really think of it's weird, I don't think of myself really as an engineer, but there's people who, I don't know, I'm not sure if that's the right term, but I don't know, there's people who have a vision and can see. So I remember hearing this, like, not hearing this quote, but I was told this during a PR review. If you don't know what a PR review, it's like a code review process for where your code gets reviewed before it gets merged in. And during one of the reviews I had, the person told me, dude, don't you dare bend to the will of the machine. You bend the machine to your will. And that like struck me, because I never thought about that. But all of a sudden, like, It's like a different perspective, right? So it's interesting seeing how people go to these great lengths to force the machine to do and reach what its capacity. And I don't think I can ever quite get to that level, but we're trying. And I think that's the fun part, is just endeavoring to try. It also reminds me of, there's like a quote from like, I think it was Plato's or something, where he's like, it's a shame to not see the potential of your body manifest or something. It was a reference to like actually like working out and seeing your physical potential be manifested. And I kind of have that same idea, but like for you know, this trade, this skill, especially since like there's just this biblical idea, right, about the talents. You may have heard of it, where like there's a story of 3 men. A master is about to leave, but he gives 3 servants something called talents. And talents back in the day didn't mean like what we think about. It's like an actual unit of currency, and it equated to like multiple years worth of your salary. So he gave 3 servants different amounts of talents, 1 5, 1 3 talents, and then one of them gave 1 talent. And then one of the persons, and he left for some time. And when he came back, he checked to see like, hey, what did you guys do with the things I gave you? And one of them said, hey, I invested in different ventures and whatever, and the 5 talents you gave me have been turned to 10 talents. And he's like, very good, that's great to hear. And he looks at the other servant, and he does the same thing. He turned 3 into 6, and then, I'm not sure those are the exact numbers. But then there's another servant who said, oh, master, I knew you were a hard man, so instead of risking losing the talent, I buried it underground. And the master, when he heard this, was greatly displeased with him. And he said, get out of here, you wicked servant. And took his 1 talent and gave it to the guy with the most talent. And there's a bunch of different meanings you can derive from that, right? Especially within the in the context of Christianity, right, and salvation and whatnot. But there's also a thing about that where I've been given, because people want to say, this is my talent and I cultivate it and it's all me, right? And that's like partially true. It's energy that you spend, but there's also a large component of it that's just like given, right, that I didn't earn or deserved. So the fact I've been given these opportunities and these abilities, it feels almost like an insult or a shame to not try to realize it to its highest capability. So yeah, hopefully that, I don't know, gives some insight into like my thought process behind this and some of what motivates me. That's not all of it. That's one of the things that motivates me. Yeah, kind of hard to believe in myself sometimes, you know. I just can't seem to believe the fact that I can get good with this over time. I call myself a coder, but barely know anything. Haha. Because of you, I started using Dropboxing. Let's go, dude. Super cozy. Your mine's be different though. Yeah, I haven't actually used I made my own custom theme, but the theme is here on GitHub. So if you want to use the theme that I'm using in my terminals, it's right here. It's just called Rustic Leather. But I'm glad to hear that, dude. And don't feel alone in that, because for the longest time, I didn't consider myself a programmer. And honestly, for my current job, when I got hired, I was very much underqualified. Like, legitimately, I was very much underqualified. It's not like a hyperbole when I say it's a miracle from God that I got this job. But a lot of people will be in that situation and like maybe label it as like imposter syndrome, right? And there's a real thing like of imposter syndrome, but in my situation, it was like this correct realization of, oh, I am not equipped to actually do this job well, and I don't have the knowledge for this. And in fact, a lot of my jobs, I've done some like really unprofessional like work just because of like my iniquity, right? But that's part of how you learn, right? So
The first thing is like, dude, we were all crap programmers at some point. And in fact, a lot of my life has been kind of stagnant as far as programming is concerned, because like I just thought I was too bad to do this, and I just didn't really venture to learn or grow more in it beyond like my comfort zone. But where I started growing is being put in these positions where I either have to grow or fail. And that was a great motivator, and that's a great way to learn. And in fact, this is a thing that happens all the time for me at work, is that I'll be brought into a room and they give me an assignment and I think to myself, crap, I don't know how I'm going to do this whatsoever. But a cool thing happens is that when your back is against the wall, you learn to overcome. You'll find a way. And there's times where I got off a meeting and I just knelt down and prayed, because like, God, I don't know what we're gonna do, man. I need your help here, man, because I'm not sure how we're gonna make it at all. But you know, He comes through, and I've grown, and that's how you just get better, dude. We have to make a 3x3 determinant. So hopefully that's encouraging to you to hear, at least, that like legitimately a lot of my time as a programmer has been kind of stagnant, and you can grow, man. You can overcome that, and part of it is just doing, dude. And change is like incremental, dude. Happens over time, and it happens in different levels. But that's a cool thing where like it's a bunch of little steps, and then once you look back, you look back, you go, oh, you realize, oh my goodness, I did a bunch of stuff I didn't know before. Some critical skills start with like, hey, I hear this thing get mentioned, but I know nothing about it. And then maybe one day I try a little baby version of it, and then maybe a year goes by, and then I'm faced with a problem, and I realize, maybe I can solve this problem by doing that thing I heard about. And you know, and eventually it goes from something that you heard about or didn't know how to do to something you did, past tense, and can do in the future. And that's the fun, exciting part of growth, man. Where is the thing? And even now, like when I go live, you'll see there's things I don't know, dude. Sometimes I'm kind of sweating because I'm like, oh, I didn't think about this. I didn't consider that I have to figure out how to do an inverse matrix. But hey, dude, that's how you learn, man. Hurt your eyes after a while? Not really. There are lesser people at this time around, so it really feels good to have a talk. Thanks for your kind words and encouragement. Of course, SPO. And of course, like, dude, feel free to reach out. I'm on Discord. We have a Discord community as well. So if you want to ask questions in a forum, you can do that. Or you can always just ask questions to me directly, and I'd be very down to answer stuff. So we have our determinants. I found it. How do y'all find streams on YouTube? I can't search up Cozy Cabin Games live stream. Yeah, it's weird. I don't know. There's some other people called Cozy Cabin, so it's a little name conflict there. But it's okay. My lawyers will be, my army of lawyers will be in contact with those people very soon, and we're gonna just send some families into poverty, dude, as you do. All right, determinant. So this determinant is composed of these determinants, which is using this A, B, C, D, E, F, G, H, I naming, so that's not great. I don't like that at all. So we're just gonna try our best. So there's two determinants. Yeah, we're gonna figure this out. You know what? Honestly, I should just Wi-Fi'd it. I could just name it the way they have it named, and then I'm gonna be less confused, and life is gonna be good. That's hardcore? What part is hardcore? Yeah, dude, Matrix Math is super hardcore, man. Amazing setup, Holy. Thank you, dude. I appreciate it. Wait, was he hating on Kling earlier? I was, Monsi. I was. I'm a certified Kling hater. Honestly, I'm a certified anything that isn't GCC hater. What can I say, man? What can I say? What can I say, man? Why pretend to appreciate inherently inferior compilers? Am I right? Alright, I'm gonna stop joshing. I should probably play Tears of the Kingdom at some point. Haven't done that. I should try playing my Switch on this, but I've also been kind of a Nintendo hater as of late, so maybe I'm just not gonna do that. Maybe I'm gonna continue my personal Nintendo boycott. Cause gosh, man, I feel so perplexed with Nintendo. On the one hand, I love their games. I love the things they've done. They have a great history and legacy. On the other hand, they're kind of terrible. They're kind of eroding consumer rights, dude. Day by, like, so many rights, actually. It's terrible. You hate to see it. Yeah, I hate to see it. Okay, we're gonna open this image in a new tab. Thank you. Okay, we're gonna zoom in. Come on. There we go. Dude, let me see the last one. There's another Matrix there, but I can't see it. It's hiding from me. Stop hiding. Like, I move it. Why you gotta do me like that? Okay. D, E, E, G, H. You think Tears of the Kingdom is so good? It looks pretty gnarly. Like, they took it... Because when I played Breath of the Wild, I was like, alright, I don't know where they're gonna go with this. But then I saw they kind of just made a... It seems like they made a game engine. Am I wrong? Like, you can construct so many different things in there. And then I saw their talk and how they're using the Havoc engine for their engine, for their physics simulation, and some of the issues they encountered with it, which is pretty gnarly. But I have yet to actually play it. I haven't seen Hydrated Ganon. I've only seen Dehydrated Ganon. So maybe that's an incredible... You know what I should do? Maybe I should just pirate. Maybe I should just boot up a good old emulator and a good old-fashioned ROM and hit the high seas. Yarg! Maybe I should have a pirate-themed stream where we play Tears of the Kingdom on an emulator and I just play like sea shanties in the background. I think it's really fun how they recontextualize the map from the first game. Oh, interesting. Yeah, because they're not making it. I didn't even realize that, but it's not a different map. It's the same map, or at least the same world, right? With changes to it. Okay, so we have our determinants. Are you proud of me yet? No, because we have to do our 3x3. Okay, and then we have the final thing here, which means that we have to also multiply everything here by coefficient, which is going to be 0f divided by 3x3. Yeah, I've grown to really appreciate design work in general. Like, it's weird, but like I feel comfortable programming. That's fine, right? Like I feel settled there. And now I'm starting to occupy the space of like trying to deal with design problems. And I didn't realize how difficult design is. And it's making me appreciate the gonads of designers to commit to a design and see it through. Like, there's something about that that's kind of really I've grown to respect quite a lot and recognize that it's like a very specific skill set that I feel I'm very much lack, which makes me appreciate it even more. 3x3 determinant. Cool. So we have that. We have our coef. And then finally, we just multiply everything in this matrix by that, if I'm not mistaken. And I might actually just move these back to being in line. Who knows? I think I might have to give it a play one day. I'm going to another road trip soon. So I don't know. Maybe we'll pack in the old Switch, or install a Switch emulator on my Steam Deck. One or the other. Okay, cool. All right, so we have our determinants. We have basically everything for the final result. And then finally, we have to multiply. We have to multiply this world position. No, not the world position. To local space. Right, we're converting a world position to local space, which... oh, this is for the world space of the object, not the... Oh. Have I done a boo-boo? Have I done wrong? Let's specify this is object position. Yeah. Okay, we didn't do a big boo-boo. Small boo-boo. It's okay. Small boo-boo. And then don't need that. So this should be, I think, straightforward. Float. So we're gonna return F2, and we're gonna do, this might get pretty verbose, because it's like when you do the multiplication, it's just gonna be this times x, this times y, and this times z, but there's no z value in this context. So that would just be 0, I guess. Yeah, because we're not doing a float 3, we're doing a float 2. So, and then we do, yeah, it's just this times x, this times y, this times z. So we actually don't need this x and y term, now that I think about it. Or maybe it is, I don't know. Pardon me, guys. I'm a little out of water real quick, so would you excuse me as I perchance grab a swig? And as I grab my swig, let me open up C-Line real quick, and I can actually run our Cozy World thing. We're going to do the BRB. Can you run it? Cool. 1 second, guys. I'll be real quick. Just grabbing some water. The ASMR people in chat are gonna love this. I got some more nuts, some more Japanese nuts. Everyone loves the big crunch, right? Everyone loves the big crunch. Alright, I'm gonna try to reserve not doing that too much. Maybe we'll play some more games tonight once we finish up this. That was fun last night, the other night playing the finals after that stream, right at the very end of the stream. I'm correct though, that's how you do the math. That's how it shakes out, right? Wait, what? Yeah, AX times plus BY. Yeah. That's straight. That's simple. Simple maths. Okay, cool. So in this case, since you're dealing with the float 2 as well, we actually don't have to worry about the Z component. So it's actually, some of this might have been redundant actually. Times pause dot x plus m0 det times pause dot y there's no way. This is actually, we did so much redundant stuff. Maybe I should take into float 3 to make this a robust thing. Pardon me. Maybe we will do that. I don't know. Because then this would make sense. Yeah, I did say nuts, SPO. We got some Japanese ones over here. The splendid ones. With that crunch. Again, I'm sorry, y'all. You know your boy gets a little peckish. A little peckish, if you will. I love using the word peckish. I feel like some kind of villain. Like some kind of, I don't know. Like some medieval vampire villain chilling in a castle stroking a little feline as I taunt the main protagonist. And we do, this will be F3 now. You become 2, become 2, become 2. Splendid. Indubitably. Precisely what the doctor ordered. Yeah, I'm not sure how I feel about constructing this matrix every single time though. Not quite sold on it, but it's fine. Anyways, we have our function now. Yay, position to local space. And then to world would be like largely kind of the same, kind of. Except it would simply be, oh, did I do the correct? Yeah, I did the correct thing. We'd construct the same matrix here. So we have, yeah, local position and then to world. So you'd simply do, get rid of all this. essentially this. Also, apparently there's a new Zelda remake that's happening for Ocarina of Time. Again, I shan't buy it, for I am a dignified man of strong beliefs, and I won't give my money to that money-hungry, grubbing Nintendo. Oh, if Sega would return and give us another sequel to the quite popularly acclaimed Legend of Senti. You should be a voice actor? What? Maybe in another life. That would be fun. But alas, I've been forced to be a programmer. Born to be a programmer. Or born to be a voice actor, forced to be a programmer. Debt replaced with that. Splendid. So now we just take our theta, our scale. Okay, let's actually be a little bit more reasonable about our spacing. And yes, indubitably. Cool. Alright, we actually have good functions now. We actually have, I think this makes sense. And now it's so simple, guys. We just gotta make the ray tracer work. It's so simple, dude. It's honestly elementary. It's simple. We just fix the matrix. Where are we? So we did all. Let's see if this compiles first of all. Yay. Okay, let's go to 284. I know where that one's the issue with that one. 284 is that you're expecting 3, a float 3. Okay. You're forcing it to be a float 2. But we're expecting this. Yes, I understand now. Yes, I understand. What are we doing to local space? We're taking a world space vector, if I am to understand this correctly. And I think we're gonna use... Do we get the objects? I don't even know, dude. What's a matrix, Ginger? Ginger 10 Johnson? You come into my house and you ask me what the matrix is? How dare you? I love explaining. Let's talk about it. A matrix, okay, the matrix is this. It's just super simple. It's just a collection of, okay, this is actually not a mathematical explanation. This is the way I think about it, right? It's like a collection of floating point digits, or it could be anything. It could be just numbers, right? And typically they can be different dimensions. You can have a 1D matrix, which is just, you know, an array in programming terms. So this would be a matrix, a 1 by 1. Okay, not a 1 by 1. In fact, it would just be a 1 matrix. But you have a 2D matrix, and it's 2 by. If you have a 2D matrix, you have 2 dimensions that you're going to be growing in, which is like the x and y, and you result in like values like this. Or you have a width and a height, and they can be populated with a variety of numbers. And matrices are important for a bunch of things, like games and rendering and 3D and 2D applications even, because you can use a transform matrix to represent the position of an object, or the pose of an object, right? So that means the location of the object, the rotation of it, and the scale. And there's a lot of utilities in representing it that way, because then you can convert things from local to local. There's an idea of local space and world space, and there's a lot of utilities in being able to convert between those things. And you see it everywhere. You guaranteed are using applications right now that are using transformation matrix. So that is what a matrix is at a very basic, terribly explained level. And we're implementing it, or at least some usage of it, so we can do some cool rendering for our game. Hopefully that helps you, or at least, you know, answers your question. Okay, we have a lot of things that are going wrong here. Splendid. What's going on at 121? Why are you mad at? Get world space. Because you are actually, this is wrong. We should just do this. Okay. Cool, that's gone. Okay. Let's go to 130. So something's not right here about this. And I think it's mad. Invalid operands to binary. What? Well, it's saying that this is a double. So is it because we're losing? Oh, it's because scale is a struct type. Yeah, we're supposed to be using the X, Y, and Z scale factor for it. Okay, yeah. Simple blunder. A simple little mistake, but hey, it happens. It happens to the best of us, right? I keep thinking that scale is uniform, but scale is not uniform. Scale is a state of mind. The finals, Boromir would have played the beginnings. That's hilarious. Brother, I love that meme. Okay, it's kind of embarrassing, Morgan, because when you sent me that meme, what was it? Let me see if I can Google it. I don't know. Let me see the Boromir badminton. So Morgan sent me this meme. Father, I'm going to play badminton. Boromir would have played goodminton. It's so good. It's so good. But I was like, all right, how do I reply to this? And I was trying to think of something else that can fit this format. And I came up empty, dude. Came up empty. I'm not a meme head, dude. I don't have that talent. It's unfortunate. I cannot meme. But it was good. It was a good one. Also, what's going on, Kate? Good to see you. Hope you're doing well, Kate. I actually have Ocarina. I can only play Song of Time on it, though. Well, that's pretty cool and everything, but I got a recorder here. And I could play something even better. I could play a mean hot cross buns. Okay, let's not do that. But as you can see, clearly, I was actually meant to be a recorder player. But did you know there's people who play recorder like actually really good? Did you know there's people who can rip on recorder? Did you know that recorder went super hard? I got a fever. Clearly a fever from the immense joy from hearing me play such a classic. And the only prescription. Oh no. I got a fever and the only prescription is more terrible recorder. Dang. I have this Guatemalan recorder. Oh dude, I got a I used this for a song once. So if you don't know, I entered a Newgrounds audio deathmatch competition, and people really died there. They executed the losers. Nah, but round two, I kind of gave up. You have 2 weeks to do it, and I only did my submission in 4 hours. And I got this great review from someone who said, let me see if I can find it. Let me see if I can find what they said, because it was funny. Let's see. Well, where's the comment? There's one that like made me chuckle. Here, okay, he said this. Almost like you failed at making a song for the Newgrounds worst song contest. Like, there's like layers to that. It's like there's a worst song competition, and it seems like you try to aim for it, but you didn't quite get there. And I'm like, thanks. I mean, I'm not arguing. The song was goofy. It was all over the place for 4 hours. Or no, I'm sorry, 3 hours and 59 minutes on the dot. But yeah, my favorite review ever. Love to see it. But yeah, there's a group of these girls who play recorder, and they're like, there's this particular woman who like, there's a song they're playing and she just starts ripping in the background, and it's like shredding. It's like, dog, I thought this is some medieval music. What are you doing? Why are you going this crazy? Like, okay, let me see if I'm gonna give you some context here, right? I'm gonna give you some context. The original song, I'm gonna show you what the original song was. If I can remember it. What was it? Okay, recorder music. Henry. I knew King Henry VIII did it. Okay, this song. Pastime with Good Company. Okay. So here's a reference, guys. Here's the... Let's set the expectations right now. So this is the original song. I'm gonna pause the Zelda music for a second. This is the original. Or not the original, but like a more faithful reproduction of it. Which, by the way, dude, it still kind of rips. Like, I would love to show up to an event and have this play in my honor as I walk in. So now you have a context for what the song is. Now listen to these three go crazy on it. I'm not gonna play the whole thing, but like, way different vibe. Already, dude. Like, I would blast this in my car. Anyways, I'm gonna go to the part where she starts ripping. Come on, do it. Do the rip. Like, she's shredding at this certain point. Wait for it. This is what actual good recorder music sounds like, or good recorder playing, dude. All right, wait for it. Look, it's about to go down. Yo, what? I'm sorry, what? Look at her fingers, dude. Dude, what? She doesn't stop. Dude, what is this? Van Halen? Like, what is... Dude, she hasn't stopped yet. She hasn't stopped. So that's what good recorder music sounds like. That's what good recorder music sounds like. And then there's me. You get the idea. Anyways, more Zelda music. I'm sad that I can't give you money. Well, I'm gonna get a game done at some point, and you know what? You can support me there. So changes to the Fight and Flight game. I'm gonna make it PC only for the time being, because to make it actually play good on mobile and PC, I almost have to make 2 separate games. So I think we're gonna do the PC one first. When the roast is low-key kind of funny. It is funny, Morgan. Me and mine homies in Yale Tavern, yep. Me and they in mine. No, that's a German thing. Mine. Mine taverns, mate, hitting the cobblestone for some fair maidens. Good heavens, but thine ankles wish to carry a jig. That's hilarious. Gee, that's some crazy playing. Yeah, right, SPO? That's what I'm saying, dude. I'm like, geez, man. It's crazy. You wouldn't think about it. But like for any particular niche you can think of, there's someone who just absolutely destroys in it. Now, there's a Michael Jordan in any niche. There's a Michael Jordan of underwater basket weaving out there, just absolutely crushing it, making a mini civilization while holding his breath. You can be that Michael Jordan. What's going on, Turb? I'm new here. Well, glad to have you here. Make yourself cozy. And yeah, dude, it's a chill place to hang out. I'm the cabin guy. I'm the cabin guy, also known as Cozy, and we just do some game dev in here. And we talk about a variety of things that comes to mind. One moment we might be talking about people ripping on recorder. The other, we might be talking about determinants. And all my compilation failures. Build. Yay, they went away, but you're still mean. What's happening at 143? Oh, W Posey? No. Pose. Okay, build. I'm sorry, what? Why are you so mad at me, dude? Why are you being so mean? What did I do wrong? Oh, because it's L pose, not W pose. Because we're going from local space. Yeah, that's important to qualify. So we're just going to do a little S, a little W, do a little L, and then a little G. Replace everything at once. Beautiful. What is a 3x3 determinant? It's super simple, man. I totally knew about that today before streaming. It's simply the determinant of a 3x3 matrix. And if you want to know what a determinant is, simply just look at this function. Yeah, straightforward, right? Very simple. Oh, if I can find it. Here we go. Look at that. Look at that. It's easy. Elementary. A child sick with typhoid can derive this. Simply. Oh, I didn't return it. Well, that's wrong. We need to actually return the product of that. Simple. Dude, every time I eat the nuts, something gets stuck in my throat, dude. The shell of the nuts. Anyways. But yeah, if you want to see like an actual what the determinant is, I actually don't know what it is. I just know how to calculate it. There's probably some important significance to it, but there's different formulas for calculating it based off of like what size of matrix you're dealing with. Like in this case, the 2x2 matrix is just this, but the 3x3 matrix you got to do a little bit more, just a little bit, right? And then this is how you calculate an inverse matrix. I'm not gonna lie, this is gonna be one of those things where we learn how to do it once and then we promptly forget about it and just call the function that does it. Anywho, alright, build. Okay, what error we're running into now? Float 2 has no member named as Z at 143, because now we use a different parameter. Yeah, we have to make this be a float 3 position. Okay. 146. Alright, because I did that thing. 142. Why are you mad at me? Oh, because you're returning the wrong data type. That'll happen. Okay, and that went away, and then 150. 2x2 determinant. Why are we mad? Oh, no semicolon. That'll do that. We'll want to learn programming. Do you have any advice on where I should start? So, here's what I gotta say. There's 3 things you need to do. Figure out what you want to do with programming. Do you want to make games? Do you want to do data science? Do you just want to make some cool websites for your NeoCity page? Figure that out. And then look at the tools to do that. So if you're making games, you're gonna get a game engine. If you're gonna do a website, I don't know, learn HTML, CSS, some JavaScript. Ugh. And if you're doing some data science stuff, then learn Python or R or something. But I will say this though, if you want to be a well-rounded programmer with solid foundations, I'd advise just download GCC, and learn some basics of C. You don't got to become ultra fluent. You don't have to write a whole rendering engine in it. You just got to learn the basics in there. Just understand, like, hey, dude, learn about basics of types, structs. Learn about stack versus heap allocation, some of the implications of it. Just learn some of the basics. Learn what a pointer is. And then you can go on your merry way to whatever actual relevant tool you want to do for your goal. But I think it's pretty handy and pretty importante. What's going on here? I'm right. Why are you mad at me? I'm right. And you're saying I'm not. You're a liar. A filthy, dirty liar. Invalid suffix 2x2 integer constant. What? Oh, I can't do 2 times 2x. I can't start with I have to actually do like m. Because we can't start with a numeric value, which means everything that starts with like, okay, we're gonna do this. Actually, no. Actually, yes. So everything that starts, okay, we're gonna do this. GG, VG, this, S, we're gonna replace some stuff. Everywhere that starts with 2x, we're gonna replace it with M2x. Or maybe just matrix 2x, I don't know. We'll just do M2x. And then we're gonna do it globally. Okay, we're gonna do the same thing, GG, VG, S, and then we're gonna do 3x. And replace that with M3x. See, the beauty of Vim, dude. The beauty of Vim. Okay, and again at 224. We have another oopsie doopsie in typing in posy instead of pose. Pause. Well, to be honest, I want to do both the blue and red team, like protecting myself and know how to attack. So basically Linux stuff. M is for matrix. Oh, like document it? Yeah, but why would I want to make things easier for future me? No, I think the 2x2 thing is so like self-explanatory that it's a matrix. M is just a formality. And of course, guys, this is some great programming professional advice. Always remember, commenting is for cowards. The bold don't comment. The bold leave code as is. The code documents itself. Why would you want to document it? Let the code document it. Simple. 282. What's going on here, pal? Flow x3. Oh yeah, because you need to have a value. Okay, cool. And then 285. You're using the wrong. No. 85. What? Oh, that's struct. Do I not need to? Wait, it works here though. So why would it not work here? Can I just omit it? Oh, because I commented out this thing. Right. I'm gonna have to revisit this code, but we're gonna make it look correct. Or maybe we should just revisit the code now and actually make it correct before we get a good compilation going. I started programming with Python, but my university taught us programming with C, and I think that made me like 3x better programmer. Yeah, 100%, Nikev. The C is going to actually make you understand the basics, the foundations of what you're doing with other languages. And it's going to give you power and agency to make decisions. Like there's some languages where it's impossible to write performant code. That's just the nature of the beast. Because they optimize, they've designed the language around ease of use, and that in their design means that you're not going to do a lot of the fast stuff. Or everything's gonna be a heap allocation, spread anywhere in memory, and you know, it's not great. So, yeah. When you learn C, you start understanding the things that are possible, and you can start making some decisions about it. Even in C#, you do have agency, like we've talked about, but you're not going to know about that unless you've actually encountered the idea that, hey, there is a difference between like heap and stack allocation, which means that the way you treat classes and structs in C# are different. Yeah, we're gonna just do the correct thing here. Let's just do the correct implementation for all the stuff going on here. Is that a red solo or just orange Tic Tacs? No, these are solo cups. Don't worry though, I only got water and nuts. Very PG. So what are we doing? Iterating through objects, cool. We have the origin point, which is local origin, yep. Yep. Cool. We have float 3, object position, object scale. We should actually use, because the camera does have is a 3 point, right? Yeah, so we could actually just use origin.z as well. Flow 3, object position. This is a world position thing now. We've changed how this works. And we have scale, and we have offset. But things change because now, since we're going to do our collision checks in local space, then we know the size of the object. The bounds are always going to be like negative 0.5 to 0.5. So we do the simple origin check of the local space origin, and this still makes sense. We use the world space object position though for the Z test, which makes perfect sense. I'm cool with that. That actually makes sense. And then we continue on. And then we have our candidate hit position of the object, which is going to be in local space XY, and then 0.5 towards facing the camera. And then we have our delta, which is going to be candidate.hit.x plus offset, and this makes values deltas are values relative to bottom are positions relative to bottom right corner. Get this dude a cigarette. A joint. Nah, weed kills.
Actually, I'm quite a straight edge kind of guy, so I would be passing on the weed and the cigarette, but I will be taking your milk.
No, I'll be taking a glass of milk. That sounds weird.
I will please take a glass of milk, Mr. Bartender.
Shush, hush. I did not misspoke. We're gonna ignore that. We're gonna ignore that. I was asking for a glass of milk from the bartender. Anyways, all I need is my snacks and some water, and we're good to go, dude. The irony that weed kill. Yo, the irony. XY. Which is honestly just UV. So I don't know why we're calling it delta X. It's actually just UVX. And UVY. And then we have the world hit position, which is going to be I. And then we're going to create a float 3. And we need to pass in 0.5 for the Z position. And then world hit position. I'm sorry. Why do we have... Oh, because we're doing a conversion to float 3, but we're not going to do that anymore because we're actually just doing our collision conversions as float 3s. Straight up. So we can actually just leave this as is. And, cool. Do you compile? 298. Origin dot Y. Man. Which this is kind of redundant. We don't need 4 values, but yeah, why are you mad? Undeclared. What do you mean why min undeclared? What are you talking about? Yeah, we're just gonna do this. It's the temple. We just create min, max, and these simply become min, max, no. Cool. Let's run it. It's gonna crash, isn't it? Segmentation of core dump. Yep. That'll happen. What's happening? I just polished off 2 fully packed cones. Of what? Give me a drink, bartender. I'm well, thank you. How are you doing? Yeah. I used to do source mod plugin. Oh? I've dipped my toes into Python JS a little bit, C#, not a fan of C, C++ because too many confusing things like pointers. Understandable. We've been there before. I feel like pointers, you just have to do it a couple times and you start understanding it. You start getting it. But yeah, it's not like an intuitive thing necessarily. Though in C++ you can kind of avoid pointers and instead you just deal with references. It's a different notation, but it's something that's a bit easier to wrap your head around. GDB game.sh. Run. So it's running here. Hey! So it kind of seems like our actual raycast code is kind of working. Well, isn't that splendid? Isn't that simply splendid? But it's weird that it's crashing on normal runtime. So there's something clearly going wrong at some level. I'd be willing to bet that maybe it's an out of range thing for also let me vim dot build. What are we calling you? Game.sh now. We're gonna just call you game. Like no extensions or like I don't know. Quest or something. I don't know. Build. We're gonna run build. And then we're gonna run game. And it's gonna segfault. So it runs in GDB but doesn't run in normal, which means I think it's probably some weird memory thing. We're not getting the crazy out of range exceptions though. Or any errors from the UV wrapping stuff, so there's something odd about that. I could do a precaution and like do some clamping. So we can just do I have a clamp function? I'm gonna make a cozy utils library for myself. Session data, text object, application buffer, float 2, 3, math utilities. I have an int clamp. We can do a float clamp. I would have thought they had a float clamp, but maybe they do and I'm just ignorant of it. Either way, not a big deal. So we can go back to session. When we recalculate UVX and UVY, we can do float clamp, and this is value lower upper. Cool. In fact, we should do, I'll make another one, and it's simply going to be float clamp 01. That's going to be a common thing that's going to pop up time to time. And instead of lower, we're going to just do 0. Upper is going to be 1. Okay. And then we can just simply do so clamp 01 and it's just going to work. Actually, do I want to do it here? I guess I'll just do it here. Cool. Build. Yep, segmentation fault still. So I don't think this time it's not due to the UV whatsoever. So let's see where in our application things are dying. We're gonna bring back our our custom break class. Actually, no, we're not doing break. We're doing the mark. Yeah, mark. Hey, I'm still alive at, and then the yeah. So let's see where things go. I could just call mark, right? Yeah. Beautiful. So we're gonna see if we make it to the loop. Yeah, this is the kind of homebrew debugging we do here in this part of town. So we're gonna do a mark before rate test. So this is gonna be, this should be 0, I believe. And this should be 1, should be 2. Let's build it, run game. So at 0, interesting. So it's actually crashing before we even get to this point here. Interesting. So somewhere between mark. Oh, I just added that one, didn't I? Yeah. So somewhere between here. Actually, let me run it and see. Yeah, it's somewhere between. It's here. It has to do the lighting? Like what? Why would this cause any segmentation faults? We're doing rotations to the angle. But even then, like, let's comment this out. Okay, so that was the cause. That was the cause, okay. So one of these things are causing problems for us. And it's the angle that's causing problems for us. Interesting. So I'm assuming that it's not actually the assignment operation. Actually, is it the assignment operation that's causing problems? Because if it was a result of like the angle, like something like from the math of the matrix, then it would be happening down here when we actually call the ray trace stuff. But that's not the case. So that leads me to wonder, okay, are we indexing outside of a range of some sort? Because we have 01 here. That's a valid object index. So let's check out where we have our angles defined. Yeah, it's a float with an array of max objects. So that would mean that maybe we're using... Let me actually look at the function for getting objects. We have object underscore create. Or request, my bad. Wait, what? There's object create and there's object request. Where is this happening? Oh, this is a request. Okay, yeah, I understand what's going on. That's a request an actual object. But the actual, to actually initialize it with all the correct values, you have object create, which returns an object reference. Yeah, take that float, 3, shader data. Yes, we get the requested object. We use the index. We never return. That's the issue. We never returned the index. So it's using a default placement value. Okay, there we go. Splendid. Let's get rid of all the marks now. Goodbye, Mark. Mark, you served your purpose very well. And now, the final part of your service here is to be killed. So goodbye. Goodbye, Mark. Thank you for your time. And I'll be seeing you the next time the world requires your service. So now we have that working. Let's try running it. Okay, that's not correct. But are you seeing what I'm seeing, guys? There's like an arbitrary, there's a weird orientation of the object. It's supposed to be rotating. We're not seeing rotation, but this is something. Also, I'm not sure why we're seeing twice of this object. So that's a little odd. But hey, dude. I'm happy, dude. We have movement happening, dude. What's going on? What's up, Kate? Love memory. Yep. Give me all the pointers. Yeah, pointers are great. Also, what's going on? Werner? No hate, but code to me is interesting yet so boring. I don't really understand it. Maybe. I don't know. I see possibilities. In my mind, there's a path. There's a path to where I want to go with this. So it's fun working towards that. And code is cool because you get to see all the different possibilities that are kind of available to you. But it's not necessarily just code. It's rather like, I don't know, it's a bunch of different things. Yeah, Kokiri Forest is very nice. The lighting things? No, the lighting things aren't doing anything right now in Niagara. We're not using any lit shaders. So they wouldn't affect anything. Dude. Let's see why this is not working correctly though, because all we're doing is changing angle, and yet we're not getting the result I'd be expecting. I wanted rotation. We're not getting rotation. So I don't think the issue's in the transform matrix, but you never know. Let's start there. That's the easiest place to check. And honestly, I should have like a function for building these out. I think we're using both to local and to world. Yeah, you know what we're gonna make a function called get object matrix. Or build object matrix. You'll take an object reference, and then we have options here. We can return like an array, or we can just like pass in the values explicitly, or mutate the values. Like you provide the values and then we mutate it, but I kind of don't like that. So maybe we should actually make a matrix struct. Maybe we need to do that. Because I kind of don't want to pass each and every single one of these parameters into that matrix, into that function. I'd rather just have a struct that contains all of these bad boys. So we're just gonna simply, I guess we're just gonna do it, dude. And then maybe we'll consider allocating that. And I think I prefer the values, lean values. I don't know, we'll see. 4x4. And then I'm just gonna yoink these. Maybe I should just do like an array, but I don't wanna do an array. I just wanna have the actual things as I want them to. This is dumb. Why am I doing that? I should just, yes. I'm sorry, what? My muscle memory, like, yeah, A. I don't know why I froze up there for a second. I was like, no, I did the wrong thing. Screw it. We're just gonna, I tried doing some cool Vim thing. Clearly I haven't mastered it yet. So we're just doing the plebeian way of doing it. Also, we're not doing this in the struct definition, are we? Here we go. And then we have to do matrix for x4. Okay, so we have a struct. Fantastic. Splendid even. Quite splendid. And then we're gonna have our build object matrix, and it's gonna be a matrix for x4 return type. And you simply give me trade alert, you give me an object reference, I give you a matrix. Splendid. And we're gonna build this bad mamma jamma. And here we go. There we go. And then we're gonna have to let's see. Yeah, I think we'll just do this. Okay, we do that. Nice. What else? What do we do from there? These get changed, because now instead of creating a new data type, we're actually dereferencing a null pointer. No, we're not. We're gonna be accessing m dot whatever, and then return m. Look at that! Isn't that splendid? Does that not warmeth your heart? It warms my heart. And then this becomes a little less easy to reason about. Because now, okay, I don't know what I'm doing actually. Never mind, I'm freaking out a little bit, dude. Freaking out. What are we doing? I'm scared. I'm scared. What are we doing? I feel petrified. Right. These boys, they gotta go. Get these boys out of here. Yeah. And oh my goodness. We did. Well, we can Vim this out though. We can Vim this. This is a problem we can solve with Vim. So, take heart. We are actually fine, guys. I think. I'm pretty sure we're fine. We'll find out though. What do I call it? Build object matrix. Should probably specify the name a little bit better than that, but this is fine for right now. So we build our object matrix. Yatta! Now we're gonna select everything here. And we're gonna do SM replace. I'm sorry. Oh, I can't do. Whoa. Okay, we can do this, I think. M.M. And then G. We're good there. Okay, beautiful. And then I can access these and do the same party trick. Don't do this to me. Darn you, Dinkelberg! How dare you do this to me again? I simply wanted to affect these guys specifically. But no. You gotta be all... So now I have to actually go through here. Correct them. Oh my goodness, I forget. haven't configured this. Okay, but we're good now. We're all happy. Everyone's happy. I'm very happy. And then to get rid of this annoying thing. It's still doing it. It's still doing it. Oh, because I did the whatever. Alright, anyways. So we constructed our matrix now in one consolidated way. Splendid. We calculate the determinant, the coefficient, we do all the right maths here, I'm assuming. Cross-reference, I'm pretty sure we're pretty good there. We do the matrix math. The matrix math seems straightforward to me. M0 times X, M1 times Y, and then M2 times Z, M0 times X, 1Y, 2Z, 0X, 1Y, 2Z. Yeah, it's all the same. So cool. And then let me check the other function. Yeah, this, no. Oh, what is, what? Oh, that's the built-in matrix, okay. And then get world space, object position, that's that. Where's to world? This one here. Right, we're gonna be replacing this with the, 4x4 equals and then we do the same thing we did before. M.M. Perfect. Okay, so this looks, we've consolidated everything in one place. So we know we're constructing them, we have an authoritative, this is how we construct an object matrix. Now let's review it to make sure I'm actually doing things correctly. Believe that I am. But believing is not always true. So we have theta equals angle. And then cos times negative sine. That's correct. Sine times cos. That should be correct for the second one. We're not doing 3D rotation, so we're pretty hunky-dory, I think. I feel pretty hunky-dory, but who knows? Maybe I'm missing something. I should probably consult my notebook with that contains the actual function, the matrix functions, but I'm pretty sure it's cos negative sine, sine cos in the matrix in that order. And then we're encoding x and y there. Oh. Do we do anything with the z position? Are we return? We don't return m. We need to do that here too. I'm surprised I didn't do that. Okay, we're good there though. Yeah, we're doing C. Building, yeah, we're making something. We're making like a simple ray trace terminal renderer thing. Right now we have this, but it's not rotating the object the way it's supposed to be. It's doing this inverse scaling thing that's wrong. So yeah, we're gonna have to figure out what's the deal with that, because it's supposed to be rotation, not that. So we're gonna get to the bottom of it, or at least we're trying to. Though when I build, someone's not happy. Type def struct 19 unknown struct. Oh, capitalize. Oh, my bad. Okay, that makes things go away. Build object matrix. Error invalid initializer. Why? Why? At 169. I do what you want me to do. I produce a great object matrix. Oh, build object matrix. Whoopsie. Build. Undeclared first use in this function. 226. Oh, I accidentally. This got messed up by the determinant thing. Whoopsie. Oh, right, I keep forgetting I can't do deletions with that. Okay. And we're still seeing the weird behavior. It's very odd. Very odd. But it's okay. We're getting there. We at least consolidated everything, and have I consulted my little diagram here? I believe I did. Scale times cosine, negative sine, sine. This should be scale times cosine A. So we have this knowledge of how this should be configured. It's also there too. In fact, we should even like put this over here so that we have a very solid definition of like the row column. There's a term for it. It's like row column major or something. I don't know. There's a specific term for the layout of this, but whoopsie, I don't remember it. So I'm gonna put this here because this is kind of like the blueprint for what's encoded into this. No! Stop it! No, stop it. I'm trying to do something. You embarrassed me in front of Martha. Was that her name from Spider-Verse? I forgot. Okay. So we have the blueprint. If you go through here, scale.x times cosine theta. Yes, sir. Negative sine A, yeah. Object pos.x. Yes, that's correct. Sine. Negative sine. No. No, that's just sine. Cosine times scale. That should be correct. I wonder if scale's affecting this. Scale shouldn't be, but you never know. Oh, but if I do that, it's going to be a scale of 1. And these should be 0, 0. Mason's Ranch? Wait, what's going on in Mason's Ranch? I find that thing that is looping and going from positive to negative and back, and check where you're creating that cabin sprite. Well, like I said, it's two places. Either the matrix is wrong, or the way we do our ray intersection, our ray test is wrong. That's kind of the two places. So I'm expecting the first part, the matrix stuff. So far, at least this part looks correct. It looks legit. So now we're going to be moving on to, I want to check the inverse stuff one more time to make sure I'm not messing up the calculation for any of this determinant business, because that's annoying to get wrong. So we're going to go back to mathworld.com, my favorite. And we're doing the determinant for this one, which is going to be... Okay, for a second I was like, did we get the first one wrong? Okay, no. So we got It should be, keep in mind, we have to subtract 1 for these, because we start from 0, they start from 1. Like people who use Lua. So we have to subtract 1. So this is... here. This is going to be 1, 1, yep. 1, 2, yep. 2, 1, yep. 2, 2, yes. And this is going to be 0, 2, yep. 0, 1, 2, 2, 2, 1, yes sir. I think I did this right, honestly. I kind of don't want to check it, but we already started. Oh, mistake time. We did a mistake. This is supposed to be 0, 1. Whoopsie. Is it? Am I wrong? Yeah, I am wrong. Okay, there we go. We found the culprit, I think. 0, 1, 0, 2. And this should be 1, 1. And this is supposed to be 1, 2. Gee, that was really... Is this correct? Did I do it right? Yeah. Dang, I just kind of gave up there, didn't I? I just kind of threw in the phone with this one. Okay. See, this is why we check. Let me just go one more time now, because now I really don't trust myself. 0, 1. Yep. 0, 2. Yes. 1, 1. Yes. 1, 2. Yes, sir. Okay. Now I can't trust anything. I can't trust anything. 1, 2, yeah. 1, 0, yeah. 2, 2, yeah. 2, 0, correct. Okay. 0, 0, yes. 0, 2. Oh my goodness. Who is this guy? 2, 0, yeah, that's correct. 2, 2. I'm just fumbling, dude. I fumbled. So bad. So was the Matrix stuff. 0, 2, 0, 0, 1, 2. That looks correct. 1, 2, right? 1, 2, yeah, okay. 1, 0. Okay, we're good there. Alrighty. And then finally, so we're doing 1, 0, yep. That should be 1, 1. 2, 0. 2, 1. Yes. We're almost done, guys. 0, 1, yep. 0, 0, yep. 2, 1, yes. 2, 0, yes. And then over here, 0, 0, yep. 0, 1, that's correct. Now it should be 1, 0, yep. And then 1, 1. Okay, let's try compiling it and see if that fixes everything. Still doing the thing. Did I save? It's still doing it. That's weird. We had the calculation wrong, but we're still doing the thing. It's still having the same effect. That's so strange. You're tearing me apart, Lisa. You're tearing me apart. Okay, I guess maybe it's negligible because the ones I messed up I think were like the final one, which would have normally affect Z, but we're not using Z, so I guess. So we have the determinant for that, and then we do 1 over the determinant of the original A, which we're calculating here. which we pass into B. Let's actually not do this either. Let me just make this taken a matrix instead. X3. I was being lazy. And it's costing me. Okay. Darn it, Dinkelberg. Okay, we're gonna take in X4. And then let's do the corresponding correct thing. I have to actually remember. Fantastic, yes. Because me and memory work out great together. So, A is that. B is gonna be. This is gonna be so bad. This is so bad. This is so bad. Like we're playing with fire right now. Like, things are gonna go wrong. I can feel it. This is how it happens. Let me just do this so I know what we're doing at least. I can easily cross-reference the correct value for each one of them. So this is 0, 0. E is now going to become m dot m. Where's E? 11. F becomes 21. H is supposed to be E. I'm gonna remove this, but I just want to have the naming there so I know what I'm looking at. I know what this is supposed to be originally. And this is why people write unit tests, isn't it? For that just ultra confidence in what you wrote being correct. I is gonna be m dot m22. D is gonna be m dot m01. F is gonna be m dot m21. G is gonna be m dot m02. I is gonna be m dot m22. D becomes m dot m001, yeah. E becomes n dot m11. G becomes m dot m02, and H becomes m dot m12. Okay, I think we got everything. Oh no, and then these B becomes m dot m 10. C becomes m dot m 20. Okay, I'm gonna comment this out, and we're gonna start getting rid of the original letter prefix. So that we're in good hands. Yes, peak development. Okay, so taking the matrix, we're gonna do this instead. Life is good. I think. I'm hoping. So we do that, or wherever we calculate the mx 3x3 determinant, we're gonna just pass an m. And that should be fine. What goes from there? What's the other thing? Does that compile? Yeah, it does, so I'm feeling kind of good about that. I don't think we haven't messed up royally. A times D minus B times C. Yeah, that's a 2x2 determinant. I'm not going to change that. That's simple. Simple. If I run it though, it's still going to be doing the same thing. Oh my god, it's so odd, dude. Alright, let me catch up in chat. My bad, y'all. It's not scale, it's your parameters. It's flipping vertically and inverting it. It's not an array issue. It might be like how I'm calculating the ray cast. I'm trying to think though. Hey, basic matrices was only thing which I remember from university math. It's a very useful thing. A lot of great applications for it. We're trying to do one of them. We're struggling a little bit, but it's okay. That's part of the process. That's what builds character. You gotta get some trauma in your bones. That's how you grow. There's also the possibility that I'm just understanding this matrix inverse function incorrectly, but it seems like that's what you do. Yeah, it seems like that's what you do. So let me think. So I think I've crossed off the matrix stuff from our list of potential bad guys. I can look at the math here one more time though. I haven't checked this. It's taking the world position and we're multiplying it by the inverse matrix. Yeah. So M0 determinant x 1 0 times y 2 z 0x 1 y 2 z 0x 1 y 2 z. Yeah, that checks out. This all makes sense to me. I'm kind of curious about something. What if I comment out the z components? Okay, so the z is not affecting things. Okay. So let's go to the ray trace code. Let's look at the ray cast and see what it's doing. It's weird because it's like oddly. Let me try actually let me try to isolate this a little bit better too. Instead of having multiple game objects, let me just isolate it down to one. What are we using to render? We're using, I'm pretty sure we're using O1, right? Yeah, O1. This is what we're gonna do. We're gonna do all these, get rid of them, no distractions. We only want O1. Splendid. Now we only see O1. Now let me play around with some different parameters. We have it set at 1 1. Let's move it to like 50 by 50 for position. This is scale, I believe. So is position being modified at all? I'm not seeing the position be modified by this. So there's a clue that something's going wrong. Maybe not what the cause of this is, but something. Actually, let me check to make sure it's not. Well, if it was scale, it would also affect it. Let's actually try out scale. Let's make it be like 100 or something. So scale is working. And this is indeed the correct parameter. So this is indeed scale. So then that begs the question, right? How is a large position offset not causing it to be placed somewhere else? It's kind of being placed consistently at the same place. So that can mean that position isn't being factored in correctly. So what is the cause of that? In fact, alternatively, let's set position as 0. Yeah. Same place. Interesting. So it's always rendering at the same place, which means the raycast is probably doing something wrong. That is the clue that that's giving me. That the raycast is not doing the proper conversion. So maybe the resultant hit isn't being in world space, but is in local space, which would create what we're seeing right now. I was going on Illusion Hawk. What's your goal now? Oh, I'm making so we're adding transform matrix to our little game engine so we can have arbitrary positions of 2D objects. And we finished all the matrix stuff, but now we're trying to figure out why the raycasts aren't working the way they're supposed to be. So that's where we're at right now. Maybe we might take another gaming break like we did last stream. That was a good time, right? I enjoyed doing the gaming break. Ray test camera. So let's go walk through this. So cool. We also have the final hit. So we check iterated objects that are reserved. We get the local space origin. Haha. But we're doing this. That's stupid. Because... Well, actually, no, it's not. Because the camera can be in any position. So we have to actually do the conversion to local space. Never mind. Camera origin X, Y, and Z gets converted to local space. Okay, cool. This is the world position. Specify that. We have their scale, which is also like world scale. Offset is 0.5, because that's the size. We decided to make objects in local space have a width of 1, which means their extents are going to be 0.5. Maybe we can make that more explicit, but whatever. We check to see if the local space origin of the camera is within those bounds. And we use the function toLocalSpace. In fact, let's make sure toLocalSpace is actually doing the correct thing. It is. It's producing the inverse matrix. So we're good there. Where does this hit point? If hit point Z is less than... Wait a second, we set it to hit point Z is max, right? So if object position hit point Z is max value. So wouldn't it be the other way? Oh no, that's the skip condition. So hit point Z is less than object position dot Z. We continue.
Okay. Wait a second. Okay, so if any of these are true. So if x is less than min, or y is less than min, or if x is greater than max and y is greater than max. Okay, this makes sense. We calculate the hit. We're using local space origin, x and y. That's not right. We should actually use world space origin, x and y, and then negative. Well, why are we? This is a float 3 though, so what are we using this for? Right, this is the UV stuff. Candidate hit dot x. We do plus offset because if we hit like the bottom corner, it would be like negative 0.5 and negative 0.5. That should be 0 for our UV coordinates. So we plus 0.5 so that coordinates at negative 0.5 and 0.5. Negative 0.5. Coordinates at negative 0.5 and negative 0.5 become 0 instead. And coordinates at 0.5 and 0.5 become just 1. And then we also do a clamp, a 0-1 clamp on that. Okay. We create the UV for that. We do world space hit position, position object to world. We take the candidate hit x, hit y. Aha. I mean, that's kind of a redundant operation. We don't have to do, because we can just use the origin. Or actually, no. Oh yes, we can, because origin's not the origin of the camera. I need to change this, because this is rather like a sample point. So that's actually incorrect naming. But either way, we don't have to do this conversion actually at this point, because we can just do the direct, use origin directly. So let's actually do that. Don't need to do this. Or we can just construct it with origin. What? What is going on here? Yeah, we don't need this anymore. That's what's not needed. And then this becomes like negative scale, which I'm pretty sure we have here. It's O scale. Times 0.5, I think. Okay. So we are float 3 position. We pass in position. This is true, the object index, the UV coordinate, and then we actually run our little shader. And we pass in what? Test hit. Ah, I think we're passing in the wrong. No, it's the correct thing. Test hit. That's the correct ray hit information. Hit dot color equals color result. It's transparent if it's less than 0.5. And final hit equals. It's transparent, we ignore it, otherwise continue on our way. We don't do this.
it becomes, oh, actually that's actually more correct. But yeah, we don't have to do this. We can actually just provide the test hit struct. If I'm not mistaken, we're still operating at the same level. Why? Why is it incompatible types? Oh, it's a float 3, that's why. Right. I need to provide the actual, what is it called? Is it just called hit point? Hit point. Okay, cool. Where are you? Here we go. Ooh. Ooh. We're having up. Sorry guys for photosensitive. Don't look. We're occasionally hitting some weird stuff. It's when it's at 0. Or I guess, is it not? Let me scroll up. So index for range of 400 or yeah, 4 million. We're exceeding that by a bit. And that's because we're doing 556 times 200. Interesting. I would have thought clamping would provide some protection against that, but I guess not. I can go to the shader to try to rectify that, but that might be a code smell. Something's going wrong here. I'm just curious, what worked? You keep asking that motivational life. I just do it. I'm a programmer. That's my day job. Cozy, you ever mess with WebGPU or 3JS? Never 3JS. WebGPU, I looked at it, but I don't know. It's very oddly named because it's not actually just for web. It's actually meant, its ambition is to be everywhere. I think it's cool that it's going to provide like more robust access to the GPU for web apps, but yeah, it's not for me. At least not yet. Raycast is something like collision or interaction. Yeah, basically from the camera, there's a ray that's shooting out from the lens of the camera. And we're testing to see if that ray hits any of the objects in the scene or in the level. That's what I mean by saying ray test. So given a point and a direction, we can check to see if there's an intersection there. We're doing a very simplified version of it, but yeah, that's the idea. But yeah, this is quite odd. Very, very odd. These values are kind of nutty. Actually, Oh, how is this producing this value? Actually, that's very strange. How is that producing that value? Because wouldn't these are the coordinates, wouldn't they be multiplied? And that wouldn't produce a value that exceeds 4 million. And it certainly wouldn't produce this value. 4,096,000. Let me check the calculation of that. Let me go to the shaders. It should be happening within BMP sample, which is like up here, I think, somewhere. Is it not? Yeah, BMP sample. Where is the printf though? I'm not seeing the printf. There's got to be a printf somewhere. We have a specific error message for this. Yeah, there's no printf here. Can you check over here? Not found. What's happening here though? It's calculating the basic data like ray hits and camera position, but I'm not. Where would this be produced? Where would this error be happening? Because when I'm looking at our shader and the function that would be printing that out if something was wrong, because it has access to the data there, it's not doing it. I am perplexed, dude. This has stumped me. Maybe we have to do another gaming session. Yeah, you see this message here though, index exceeds. Oh, it's in CBMP itself. We go a level deeper. We actually modified the library. CBMP. Yeah, here we go. So index X and Y, and then Y is going to be. So it's being thrown if index is greater than or equal to length, or index is less than 0. Both are invalid ranges. The thing that's weird, maybe my math is not great, but I'm pretty sure oh wait what? So I referenced this. This is how they do it. So they do y times the width time plus x. So y times width plus x. And that's how they're indexing into things. Let me see something. Then we don't have to do this dereference and we have it cached already. So we have length, and then we're going to pass in the dimensions. Try building it. Okay, flashes us. This is a coordinate that's less than 2000. This should be a valid coordinate. Just take 404, right? Let's actually do the math. So for, what is it? An x of 404 and a y of 2000. Oh, is it actually a valid range? Is this inclusive? Anyways. And the rate check the path in that 2D matrix, if I understand. Kind of. We can go into it in a second. If you're curious, we can talk about what is actually going on under the hood. Let me check something though real quick. So we said y, these are the coordinates that we're checking, right? X equals 404 and y is 2000, which is like the maximum resolution. So you'd have 2000 times width. Sheesh. Okay, maybe it's not crazy this is happening. Width being like 2000, right? Equals 4 million plus, okay, x. Yeah, I can see, okay, the math checks out actually. So it means that we're passing in somehow a wrong x and y value. So let's see where that's happening. It's happening in a standard shader, I can tell you that much. So we take in a UV value, which we're assuming is to be 0 to 1 range. That's the assumption for all of this. And you multiply it by width and by height relative to y. Interesting. So what if we So I want to see what values are producing this. Also, why would the UV value be incorrect? Because we have in our math utilities, we have this clamp function that's guaranteeing that everything's gonna be within 0 or 1. Maybe we gotta make it explicitly 0. Or make it explicitly floats, but pretty sure. Yep, it's happening periodically. Okay. Float clamp 01. I mean, this is pretty straightforward. Hey, good afternoon, Senkai. Good to see ya. Hopefully you're doing well, my friend. Hope life is treating you well. Is a 0 to 1 range actually correct for this? Now that I think about it. Like, I'm thinking about it in this terms, right? But for what the CBMP is doing, it's indexing to the array. So if y is the last value, if y is the last value, let's say y is 1 times height, right? Then you're gonna do that times width, and it's gonna produce like all these slices all the way down to the last one. If we're assuming this is inclusive, then wouldn't a y of height, size height, be invalid? Like, y values would be incorrect then. Or 1 values would be incorrect for our UV thing. Like, this might be weird, but I almost feel like we might have to do like. But then 0 would be underflow as well, because 0 minus 1 would produce the negative value. So then do we just say, hey, we accept equal to length values for this? Isn't x and y flipped? Here normally is y is the column. Well, this is the way CBMP does it. This is a function I added, but this is the original function from this library and how it indexes into it. So it treats it like the coordinates are going down. So I'm just following their conventions, but maybe they're wrong. Maybe they're actually just incorrect. Unless if we want to make 0 to 1 range, fine. Our sample function needs to account for that. So when we do this and we provide a UV value and we do width, we get height. You have to do like -1 because we're gonna be occupying that full range. And that corrects for it. So I'm guessing that was the issue. Beyond that, let me test one more thing. I need to change the scale and make it like larger. And we have to address the incorrect position in our matrix. It's supposed to be rotating, not this. I'm not gonna lie, man. I want to try something a little bit odd. But we do a negative sign. I think we should just get rid of that. Let's just see what happens if we get rid of that negative sign. Same stuff. It's almost like the sign doesn't affect things at all. It's almost like that component's not doing anything, dude. Yeah, look, that's weird. Okay, so like this matrix is not affecting things. So that's that's a clue. That's an oddity. Position isn't affecting things either. So I can change, right now it's like 0, 0. If I change it to like 100, 100. We did some changes, maybe you gotta adjust. Nope, it's still oriented exactly like right here. So position isn't affecting anything either. That's strange. In fact, let's actually let's modify all these values. Oh, okay. No, that's not. I don't know why we have this sign thing going on. I thought for a second that we found the cause, but no, that's not going to affect anything. Okay, let's mess around with position. Yeah, frame count should be monotonic. For a second I thought we accidentally made it not monotonic and it was going back in time. But no. We're not doing that. So we're gonna do, I don't know. Actually, we're just gonna go with this value. For X, we're gonna make it oscillate on the X and on the Y. So it should be going in circles if I use a cosine for this. And we should see translation up here. And if not, it's another clue. Maybe the way I'm doing multiplication might be wrong. I might have to actually flip the order or something. But I think it's right. Okay. Yeah. So let's do something. Let me get rid of the angle rotation entirely. Yeah, no translation whatsoever. It should be translating. It is not, though. Health? What's going on, Ming Phoenix? Oh, salute. Good to see you, man. I hate the YouTube auto-translate thing is annoying me. Okay, so let's get to the bottom of this then. Why is position not affecting stuff? If we look at our little toy visualizer here, these components affect translation. Maybe, I know some matrix, we talked about like column major. Let me try swapping or replace position and see if that affects anything. It's weird. Maybe that might be the cause of the issue here. Daily range, RG. Let's go over to where we do our, here we go. So instead of doing X and Y over here, we're instead going to do X and Y here. So we'll do this is formerly 0, and then we're going to comment out this and make it 0 instead, and we're going to comment this out, make it 0 instead, build. That was it. Yeah, we have our translation actually happening. Okay, so I was doing the matrix math, or the multiplication incorrectly. But now we have translation. I wonder if we have to change... We might have... Do I have to mirror things? Is that what's going on here? Because I was organizing it around this. But if it's actually... XY, then we have to mirror flip. I mean, it's not a crazy mirror flip, it's just this. Right? That's what I believe. So we change sign of this, sign of that, and if we go back to main and bring back rotation, it's still doing the flipping thing though. Interesting. Why is it doing the flipping thing? Let me get rid of the translation now. What was the issue? So the where I was placing the coordinates for the X and Y where I was placing the X and Y position in the matrix. So before I had it this way, where X and Y were on the third row or third column. But in actuality, the way I'm doing the multiplication, X and Y are actually supposed to be in the bottom here. And I was organizing it this way, where this is positions, and then this is the scale, and then we also have the rotation curve. I wonder. They don't show the functions for this, but let me search it up. 2D, affine, transformation, matrix. Yeah, this is the way they organize it. Am I doing my multiplication just wrong or something? Yeah, cost, negative sign, sine, cos. Yeah, I have things embedded here. But I've kind of combined them into one matrix, these three into one. But I wonder if I need to make discrete matrices and apply the transformations in that order. But I feel like I should be able to just have it all in one. You should be able to have it all in one. Position to world. So this is a local position, and we do 0 times position x. Zero. Yeah, and that makes sense to me. Here? I know, crazy. Dude, math? Here? in programming? Get that out of here, man. I don't want to get no math. Dude, should I just do paper? Let me get my notebook 1 second. I have a notebook with some of this stuff. I did a couple of these by hand. Oh, is it upstairs? 1 second, let me grab my notebook. Yeah, I'm totally right. I'm pretty sure the way I'm doing it is correct. AX, BY. You have a Z component, then it's CZ. Yeah. I'm totally right. So why is things going wrong in this way? But you do need the multiplication in order. Well, okay, matrix multiplication is not commutative, and if you have a discrete set of, if you decomposes matrix into a set of 3 transformation matrix, translation, rotation, and scale, then order is very much imperative. But here, we're trying to bake it into one matrix, so we don't have to worry about commutativity. What monitor is that? It's a good monitor. I like it. It's a fun monitor. I enjoy using it. Let me check to see if our inverse is working as expected. I'm pretty sure we checked it though to local space. So we take our matrix that takes a local value to a world, and we're going to invert it. And we do this whole thing with the coefficient for the determinant and multiply it by the matrix 2x2 determinants. So far, so good. I've named them correctly. 0, 0, 1, 0, 2, 0. 0, 1, 1, 1, 2, 1, 0, 2, 1, 2, 2, 2. Yep. We checked we checked these values here, so they're all correct. And then finally, zero, 1, 2. Yeah. The world wants me to think I'm crazy, but I'm not crazy. And this is taking a world space position, an arbitrary world space position, and doing that conversion into the object local space. Yeah, Nightbot B, there's a bunch of bots that are just kind of sleepy on our channel. Like even the Discord, the live bot isn't always good. Also, Wooden Litting, welcome, glad to have you. Cool. Responded to them. Hi. Where? Oh, where had my little heart gone wrong? Where have we gone wrong? Position to local space. Yeah, it's a weird thing that we're facing. The fact that we can poke and prod the core matrix and nothing is getting like the changes aren't being represented. And that's strange to me. Very strange. It's nice if you have like at least translation on the table, but yeah, we thought we were gonna be able to do some Cindy and AVX stuff today on stream, but as always, dude, things seem easier than they actually are, dog. Things seem easier than they actually are, but that's okay. Oh, what's going on here? Right, we did the reordering, yeah. So now things are... We're on layer 2, the last layer, and we're doing X, Y, Z. We made second column sine be, you know what, we're gonna... Sinusoidal functions are coming first. We're not doing scale. Scale's optional. We're usually gonna have a sine function. A sinusoidal function, even. So we're gonna just put those bad boys first. Cos theta, sine theta. Okay, so row 1. Yep. Yep. Negative sine. Cos. Okay, this is what we're gonna do. We're gonna start substituting things here with just like scale X until we see something change. That's what we're gonna do. Oh, there's a rotation. Oh no, it's not. It's still doing the flipping thing. But not only on the Y, not on the Z. Okay, so this is affecting stuff. And if I replace this with 0,
Build. Build game. So that's not impacting anything. So you're not affecting things at all. Interesting. No effect. Okay. We're gonna go over here. I'm gonna comment you out. 0. Oh, I thought it commented you out. So now there's no... That's kind of what we saw before already. Oh, let me introduce cost back in, I think. Because it's kind of hard to gauge. But it looks pretty much the same. So I'm going to say this is no effects. And then finally costs, which we'll replace with scale.y. There's some subtle changes that are happening. But it's not clear. Is sign data actually affecting things? Is it just like to a really negligible degree? Do I need to multiply it by scale as well? Maybe that's what's happening, is that sine and cosine are affecting things, but I also need to multiply them by scale for it to be correct. Oh my goodness. That's kind of great news though. Great news! Good news, everyone. In which case, we just do scale.x and scale.y. I'm hoping that's it, dude. Oh my goodness! We got it! We have arbitrary orientation, guys! Let's go! Let's go! We have rotation in the game, ladies and gentlemen. Our transform matrix is working. Let's freaking go! Let's just flex the degree of how great this is working. And like oscillate everything. Dude, I'm so happy. The engine rises day by day. It's getting better and better, more and more robust, dude. I'm loving it. Let's do a higher resolution. I found that there's a shortcut in this IDE, or within the Westterm, to resize things. I just need to do, I believe, this, and I can have a really nice small terminal size. Oh, brother. Brother. I am so happy. Oh, dude. Do we try to go for the AVX instruction stuff too? Thank you, Illusion Hawk and Senkai. We have... The cabin's rotating, man. Get rotated, nerd. I need to do some performance profiling at some point, but this is fine. This is fine.
I'm quite happy with this. Dude. Oh, and it's a per instance thing, so I can make this instance really small, but everything else can be fine. Dude. Ah, man. This is so freaking good. I am so happy. We're in there, dude. We're in there. We're so in there. Let's save our progress. Implemented affine transformation matrix. Dude, we crushed it today, man. And it's still before the next day. It's 11:59. We got it at the last minute, dude. Let's freaking go. Salute, dude. Oh my goodness. What's the next thing on the roadmap? We can do some optimizations. We need to fix the lighting system. That's the thing we need to do. We should probably try this out with the lighting system. I mean, it should be pretty straightforward though. You're gonna just use pretty much the same stuff. I just need to specify that you're using the standard lit. Of course, zoom out a little bit. Yeah, I mean, you can see it's being, okay, it's kind of lit, but it's also not. So we need to address transparency, because transparency is being weird with the, that's easy. In fact, I think that's just like a one-line fix, at least in that part. Then shaders. Like, it might be as simple as just what is it? I kind of want to make a macro for discard so that it just returns 0. Yeah, you return albedo diffuse A. Do we use albedo A at all? That doesn't matter, because if it's like less than, if it's transparent, we just return. Oh yeah, it's called C4. That's the name of our type constructor for it. C4 is gonna be just 0. Did I not have color 0? Whatever. We're gonna call this define discard, and it's simply just gonna be return C4. So I should be able to just do discard. Yay! And we fixed that. So now we have lighting. Cool. Well, we should be able to have multiple lighting though, and the multiple lighting thing isn't working that well. How many lines of code does it take? Not sure. Couple hundred, that's for sure. I can tell you that much. Probably a couple thousand. That's alright. I mean, the source code's on Codeberg, so if you guys want to check it out, you can just check it out there. Cool, we got lighting though. Yay. I'm sorry guys, I'm just so excited, dude. This is like so freaking cool to me that we got this working as well as as we have it. Like, it's just so freaking cool. Let's see here. Dude, I think we just take the W's for today, dude. I think we just say, hey, we're winners. We won. Life is good. And just call it a night. Yeah, I'd consider maybe doing gaming, but yeah. I gotta go to work in the morning. Let me save what we have. And also, I'm free to answer some questions if you guys got any comments, questions, or concern. Transparency and lit shaders. We have to do transparency at some point too, but I don't actually care about transparency that much. We'll see, maybe I will care. As much as I want you to continue, I think you're right. Go to sleep cozy and happy. Yeah, we won today. We got a big win. I'm super excited. Like, we're one step closer to being a better, more robust engine. And I think next stream we're gonna start diving into the AVX stuff. So prepare for matrix math. Okay, not matrix math. Prepare for Intel instruction sets. Prepare to be calling functions like _mm256 add _EPI. Actually, no, you're not using EPI. We're gonna be using PS. Yeah, PS. Single precision. Yeah, PS totally stands for single precision, right, guys? Or precision single. I actually don't know what PS stands for. Actually, I'm kind of curious, because this takes, what? 2 cycles to do a 256-bit add. 32-bit floating point elements in A and B. And the stored results in destination. Yeah, this is for 256 bits. But if I'm doing SSC family level of I'm doing like old school SSC. What do you have for me? Yeah, mm_add PS. It's 128-bit register that we're going to be doing stuff with. Add packed single precision 32-bit. This would be, well, it's 128. So, dealing with 32-bit floating point element. So that's what? 4 floats that we can like do a single cycle add. That'd be good enough for some of the stuff we're doing. I think if I was doing more robust things, we can design around the AVX2 family, but I think if I go down this route, we're gonna have to do some AOSOA instead of SOA. We're doing a lot of SOA stuff. Everything we're doing is pretty much SOA. Kind of, actually. Not really. It's weird. It is, but it's also not, because the floating types I'm dealing with, they're all aligned. They're all like, they're still structs underneath the hood. So if I actually want to leverage it, I might do like a AOSOA structure instead. But then I have to decide like what kind of cache. I guess we're gonna try to fit it into the cache line, right? But I have to look at the ray trace code to see like how's our cache performance, and They were probably blowing cache pretty badly, if I'm gonna be honest with you. Actually, no, I think like everything fits pretty well within cache. We have the Linux counter stuff, so we can actually see how well our L1 cache hits, or L1, L2 cache hits and misses % are, and then we can start using that to profile. Because the ray tracing thing is going to be, but that is primarily testing against transform information. And then we can do the multi-thread thing, but that's a separate idea. That sounds super fun. By the way, question before you go: do you normally study the things you want to implement in stream or during stream? Sometimes I study it a bit before stream. Hey, I was going on NV Creator. Glad to see you. Hopefully you're doing well. Hope your evening's doing well. As for that, sometimes I do it's like for the matrix stuff. I did some basic stuff on this notebook like a few days ago, just out of curiosity. But I didn't plan everything. If you look earlier in the stream, we had to go through this. Someone in chat had to help me out and specify, hey, this operator, because I didn't know how to do. I decided at the last minute to do an affine transformation matrix instead of a 2x2 matrix, and that is significantly different because it's very trivial to calculate a determinant. I didn't know that's what I was doing before for a 2x2. But like getting the inverse matrix for a 2x2 matrix is super simple. You just flip it, make these two negative, and then you calculate this coefficient, and then you multiply it to everything there. But for a 3x3 matrix, which we just decided to do today, it's way more involved. Look at this. It's a matrix of matrix that you're doing. Well, really, you're calculating. You're calculating the determinant, but I didn't know that's what you're doing. Like this line here, I didn't know what that was. I thought it was like absolute value, but no, it means determinant. And a calculated determinant is a very specific thing. So, yeah, I didn't know that. So we just went through the process of Googling and figuring stuff out on stream. Thanks to the help of people here. And, you know, we got it done. We figured it out. We made it. We got it. We got the good stuff going. We got rotation finally working in our little game. Or our little game engine. Let's say that. Oh, whoopsie. Press the exit button by accident. So, yeah, I mean, usually though, I don't plan anything for the stream. Usually it's very much like we just wing it and see what happens. But yeah, so many tabs, not enough tabs, Nicey, honestly. We don't have enough tabs, not nearly enough tabs. But yeah, usually streams I'm winging things. Or figuring things out on the spot. Only with something very particular like this is usually I kind of think about it a little bit. Not for the purpose of the streams usually just out of curiosity, like what is this going on? How do I go about doing this? But yeah, the AVX stuff is going to be fun to think about. Oh, they have a specification for the type of, that's EPI. Where's PS? Okay, M120, no, that's the AVX. Where's SSE? Where's SSE? So there's divide, there's add. Which is what I'm usually doing. Like if we look through, again, we're gonna have to actually sit down, but where is mult PS? Okay, M underscore 128 or underscore M 128, 128 bits. And this does what? Multiply packed single precision 32 floating bits elements. So it's 32 bits, there's 128. That means we have 4 floats we can work with. So we can multiply 4 floats against another 4 floats. So we can do like a float 4 multiplied by float 4. And that'll be perfectly fine and suitable. But we're not doing, like, this is more intensive. We're doing like some physics simulation stuff, I think, where we're iterating through a collection and applying this fixed set of operations on top of them. Let me check the shaders though, or not shaders, the ray tracing. Let's find it. Okay, yeah. Ray test camera. So under the hood, when we do ray test, a single ray cast, so we're loading it here. The matrix stuff is 100% gonna be the big thing. Yeah. So we can definitely accelerate that with some AVX, I think. That's actually gonna be pretty trivial, I think, to not paralyze, but to speed up with that. What else do we do here? We have the clamping thing. You could probably do an arithmetic, like an analytical approach to clamping instead of doing this function. Or we can have them all implemented there, because we can use defines with GCC. And then we can indicate to the compiler, hey, we're using with support with AVX, so we can use that. So this is potentially a place we might want to do it. I don't know. Yeah, shaders all of a sudden become a place where we really need to do that, actually, now that I think about it. In fact, that's probably the most intensive thing, because with the shaders, a lit shader specifically, you are iterating across all the different light sources. So if you're iterating across all the different light sources, yeah, that can balloon up in size very quickly. Yeah, max lights. So we have this distance calculations. Thankfully, I'm using mostly just the functions in there, so we can just go into the float 4 functions or float 3 functions and do the math there. So you can do a fast distance calculation, fast-ish. Yeah, we're doing an add. That can be AVX'd as well. Yeah, this function can definitely, yeah. So there's some definite, I want to do a profiling. We need a profile. I want to do a substantial profiling of the application as it currently stands. We want to do a multi-sample profiling for the different areas of the loop cycle to see how much time things are taking, and then we can compare it to see how much we've saved by using the intrinsics. Hell no, I'm ADHD, I can't. Dude, I'm ADHD, that's why I can. Music playlist, Joe, here you go. Here's the playlist I'm using. Here you go. Be for the full stream, so I was wondering. All good. You should probably have small benchmark before applying AVX to see difference in number. Yeah, that's exactly it, Senkai. Yep. Because there's other things too that can speed things up beyond just AVX. Like there's algorithmic stuff you can do. There's also different memory layout stuff we can try checking out to see how fast we can go. Like we mentioned, like there might be a need. I need to see like what kind of. I need to look through the loop and see exactly where cache, like what memory is being pulled in at a given moment, to think how we can keep things very cache friendly, and if it's worth having. Do I really want to do, like for example, do I really want to do an array of float 3s? Or do I want to? Here, like we're doing an array of float 3s, and maybe that's fine. Or maybe I think actually might be fine for what we're doing. There might be like a want to do something different, like have it sized better for a cache line. So do like a float, an array of a different type, like a float 3x, I don't know, 8, or something that fits more evenly, or maybe float 4x 8 or something. But something that fits nicely within a cache line, so we can make loading things into SIMD registers easier. But I don't know. We're thinking too far in the future. Let's just see where we go from here, and then we'll decide. What are we doing here? Well, we're kind of winding down for streams. We implemented a whole transformation matrix today, and it's working now in our little ASCII rendered game engine. So you can see arbitrary rotation is working. I feel pretty happy with it. I feel pleased as punch. Like, look at that. Look at that. That beautiful ASCII. Beautiful ASCII rendering. And now we're just thinking about future plans for potentially optimizing and making this go faster, but we're blind as far as performance is concerned, so I need to check that out and see how it's looking, and then I don't know, we'll see. And who knows, dude, man, we can start learning about more advanced, cooler, weirder things like cast associativity. But I don't think we're at that level. I need to learn just how to use AVX first of all, so we're not going to worry about that yet. Maybe one day we will. Anyways, ladies and gentlemen, I do declare we have reached the end of the stream. Where's Stream World? I had it open somewhere. Did I close it? I guess I closed it. Did I really close it? Mar? No, so this is a completely software rendered thing. This is a software rendered thing. We're not going to use the GPU for that. We're not going to use a GPU at all. We want to do everything purely on the CPU. And we're going to learn how to squeeze the most out of it. Or at least, as much as we need to. But even if we're not using the GPU, there's still ways to do some level of parallelization. So we talked about the SIMD/AVX stuff, but the other thing we can do is that we can do, we can also break up the sections of the screen that we're doing ray tracing on into multiple threads. So instead of having one thread iterate through the entire space of the camera and then shoot out the samples, ray samples, we can instead divide the screen into like different sections and have each thread go off and calculate the resultant values for their portion of the screen. So that might be worth doing. The thing I'm thinking about though is that like the resolution we're working at for the ASCII render is pretty small. So I wonder, I'm pretty sure like the overhead for like spinning up threads is not gonna be that crazy. Or maybe we just have these threads just waiting in the background, awaiting work. I don't know. There's different ways of doing it though. So yeah, there's different ways we can do the speed up. We can do an algorithmic change to try to optimize for that. Just see if there's changes in like just improving our algorithm. Because our algorithm is very much a naive approach. There's a SIMD stuff, and potentially like restructuring our data to be much more cache line friendly. And then there's the parallelization route as well with multi-threading for dividing the work of the screen rendering into different separate jobs that need to be executed. Cool stuff, fun stuff, and I think it's a nice technical challenge to try to like get better at programming. And it's not always things that you're gonna have an opportunity to do in your day job, right? So why not try tackling this kind of stuff here?
So yeah. Anyways, ladies and gentlemen, we have reached the end of the stream. Thank you for watching as always. And remember, God bless. And until next time, stay cozy. Ta-ta.